Hi everybody, good morning. I'm doing this Mayhem TryHackMe room. I did a video yesterday and I uploaded this morning, and there was an issue. It's not a plane, it's like a black screen, and of course you upload the video for 1 minute, there's an issue with it, you get straight dislike. I don't know, these people sometimes no appreciation, sometimes I don't know. You see a video, there's a problem of 1 minute, you just give me dislike. It's like, I don't know, sometimes the TryHackMe community sometimes you spend the whole doing the video, getting the resource right or something, and then any case, this mayhem is the same pattern. If you The room creator Hadrian is usually there's some kind of process doing communication in Wireshark, and then you intercept the communication, and there's some kind of encryption decryption that you need to do. Uh, of course, now when you do Wireshark, you get this communication. If you start, you can see the port 1337 already communicating there, and then switch to port 80, things like that. You can even, isn't too many packets, you can just look at them here. You can see there's an install PS1. Uh, of course, you can go to statistics and you say good, for example, the endpoints. The IP4, you can see two IPs are communicating this one less packet. We're not interested on them. Uh, the TCP, it gives you, as we said, there's a port 80, there's a communication here on a byte. This is not, how many of them? This communication between the 38, no, this one is not interested. 38 and the 37 in port 1337. Then you have all this port, you have 600 byte here between them. This is the statistic for the endpoint. We can check the statistics for what's that one, conversation. Here it give us it start with the 1337 ports, and then switch to here the 38 in port 80. So we have a communication in port 80. So it gives us an idea what's happening in Wireshark. Seeing that give you an idea to just go to usually export object. uh, yes, it's in get requests, you can see them. This is the same things as so people they talking in Discord. They found two notepad. There's only one notepad, you can do the MD5 or SHA. And then interesting, you have that install the PS1. The install the PS1, we can get it, this one you just can follow, for example, download it or install it. You can see what is it here. So that PS1 is downloading from the, so we know the hacker IP is 110.0.2.37, and you can see here a simple HTTP Python. So he has a Python server like we do in TryHackMe. When you attack box, you run your own server and then you download whatever your payload. So he did simple Python server. Then we have an upload, is downloading uh, a file called notepad in a user paco directory, and then this is just PowerShell to run it. So we know now the target. So where is that? So your next move is, because you know there is what is this? Is my computer the evidence? The Mayhem. So you know this notepad. I test them. They are the same things. So you have the notepad binary. You have too many options. You can check Hydra or something, and then one thing you can faster just go to attack box. You can attack box in virus total. You can see there is flagged. So one thing, if you go there, different names, for example, the binary relation. Interesting part in relation is the IP. So it means this 10.0.2.37 is hard coded in the binary to communicate to the system. So which explain after the download, after the what I'm doing. Let's remove the follow. So after the download, you can see it's communicating to the server here, the bottom ones in this port 55347 is communicating. 38 is the client is talking to the server, and then we have a server talking back. So you can have an idea. It's a C2. Now the question, what type of C2 we have? If you go to one of the comment here, for example, it give you part of the answer. For example, he said, "Hi, this is seem to be an open source tool or framework. The author has shared it to community with intention to improve overall security, and we take us is Havoc framework." So now we have our first point, Havoc framework. Now, if you Google Havoc framework, this is the details. With our friend, this is the wiki for Havoc. This is Havoc framework. So we know it's Havoc because of the command. We're not confirming it yet. You can see it's a bit fancier if you want to play with it. So you can have an agent, and the other one they call it a team server. Now you can run around this ones, or this is the script. This is the wiki if you want to how to install it. Documentation. Um, this is the installation, all of that, but we're not interested in that. We are more interested how, for example, in communication, a protocol for it. This interesting part is say each packet is um, what I'm doing now. Yeah, each packet you can see it has it tell you the team server and the Havoc agent communicate with each other by sending raw binary data. It is a file I'm missing or something. Give me a second, guys. Let me check something. Alright, guys, I'm just checking the video is working again, and I don't need to record the video again. So in the communication protocol, it said you the team server and the Havoc agent communicate with each other by sending raw binary data. Uh, where is this? This is the script. Let's open that. So we have it tell you a 4 byte and the size, and the magic value, and then the agent ID and the request ID and the command ID. And then interestingly tell you the magic value is set to hex value .pef. Now this is our sign here. Can we find it? If we find it, we can confirm is find packet, we leave it in hex. Let's see if we find this .pef, and you can see they all here .pef, so we know it is it. And let's see to confirm where it start from. You can start here. You can see at 38 is sending to the server 37 uh, source port, and the destination is talking, and he sent a length of 333. So this data was sent. Of course, if you go follow, for example, HTTP stream, you can see this encrypted data we can see, but sometimes you can use it a normal is not encrypted, for example there. And then if you continue down, you can see another data chunk is encrypted, and then another, for example, they differentiate. But if you look, for example, here, for example, let's remove the stream. uh, if you investigate, you can see here is post, for example, let me start from the top where it start. So it start first here, and we can see the signature DEADBEEF, which confirm your next. Then this is the client sending to the server 37, and then the 37, this is acknowledgement, and then there is an OK request, and you can see another OK. So you can see maybe the server is sending back commands. The next post request is this, but you can see is 74, and the data, where is it? I always have a problem to find it. This is the post request. It's a 20 byte. You can see 20 byte, which is give us an idea, because 4 by 5 is 20, 20. So we know the 20 byte here. And when he send a 74, we have this is a reply from the server. And next one is you see the 182. Where is the next post? The next post is 74. The 74 always 20 byte. When it's 74, you look, the reply is 182. And you can see it's all 0A zeros. So it means they are not sending commands when it's in this state. The 182 and the 74, they just like a beep or something. They just signals. They are not sending or doing anything. And you get a couple of these 182, you get a 74 too. So whenever you see this is 20 byte and the server reply, the server is 37, is sending the 0A. Now we know basically where is it. The code, no, this is not the code. This is the communication protocol. This is the Havoc. I forgot where the code is. Redo the. No, this one is Havoc, the main one. I'm not sure, is it the team server? Yeah, there is some codes there. If you look inside them, you find this part of the this one, how the script is doing that. So we get an idea. Now if you Google more, you get a couple of websites that are talking about Havoc. This one is talking about it in Microsoft environment, and it gives us also an idea what we've been looking now. For example, if you look, it has there, and we talk about this is more doing reverse for it. Where is that things I want to show you? Yeah, the command ID 0A. Also, we only observe a diamond command no job. So the 0A is what we got here. So all this 0A, this no command was sent. Another one, very good one, is this one. This one is more, it gives you more analysis. For example, this is straight to Havoc. Havoc C2 framework defensive operator guide. And the resting part, they do different techniques, but it show you how Havoc use getting the key and the IV, and the big, and you can see the DEADBEEF, but this is the screen the most important. There's the way of the first packet. The first packet is the way that Havoc. There's no bigger screen for this to show it, but that's how it look. You can see the DEADBF and so the key will be in the first packet. So the first packet is this post. So if we copy the data, where is the data? So support the destination Windows. I can't see the payload, TCP payload, copy value. So if I just come there, you can see how this should if you follow now this, you can see this is the length of the field, the DED, then we have the agent ID, and then command ID, then we have the IS key, and then we have the IV. So if you follow that structure, so we have our the signal DEBF. So we should have the key. It's a 64 bytes, so it should be somewhere here. And then we have where's the agent ID? Oh, I did mistake. The magic bytes. No, I think I did something messed up here. Let's go back to. You get the magic byte. Okay, so that's what that 003 came from. Let's put back. So we have the dead biff, that's the magic byte, and then then we have the agent ID, which is this part, and then that's a command, and then we have the key 64 byte, and then we have the IV32, and then we have that. So basically the same things we do. So we have that header, remember we said the header, but the first header, it have the key. The other headers they come in later on, they will not have the key on them. So only the first one have the key. Now to confirm that we are in the right path, the question is, can we do that? So if I go to IS, decrypt IS, I can just say, can this key is what we have. So if our math is correctly, so we can have that. And then the code will tell you Havoc CTR. If you follow there, it use CTR encryption. Now let's see if this thing works. So if it works, so we can decrypt this text there. So let's see, and you can see we get some kind of decryption. We can see Windows, the name Paco, listener.TryHackMe, the IP, FC user, we get downloads, we get notepad.exe. So we can see for sure that that we got the key and all of that. Of course, if you go also in this one more detail, but it tell you of a structure, because it's the same pattern. You get the DEADBEF, you get that, then you get the command ID, you get IS key, the ISV. So we got that fine. Also here they give you a nice script. They give you, for example, if you go to the repository, so if we go to, this is mine, this is the Havoc team server, this is there, that's the script they're using. This script didn't work for me, because usually this script, if you run it, it detects the command this way, but as we want the original command, we don't want this, and we don't want this. This is the script of theirs that's supposed to give you the key. We'll test it now. It doesn't work for me, so we did some update to it. Now let's do first the manual way of doing things. So we got the key, we got we got the key, we got the IV, so we just can go to, so this is the first packet. So what's the next post? The next post request is this 74. We tell this 74 is not, we are not interested on it, because it's only it's a bit like a 20 byte, which exactly the just the header, so it's not sending. So we need to look for the ones that are not 74, because where is it? It's only 20 bytes. You can see your where is our dead beef? DEAD beef, and there's no command, so we are not interested for reply for that. Your next post, you just search for them like that. 74 is not. Next, where is the next one? And now we have 5835, so this is a long one. So now we can where is the media type? Like we can copy the value here, the value of the post. We're not taking the head of the post, we're taking, you can see we have the DED, where is that, DEAD. So if I come here, so this is the one, the first one. So now this is the second one, you can see all of it. Now we need to decrypt this one. So if I go to my there and you just put, of course it will not show. The reason why it shows, because remember the first 20 bytes, so it means the 40 are not the header, so we need to remove that header. So we can do slice in drop bytes. We can drop, because it's 20, so it's 40. So if you remove the first 40, then we can get the decryption of which we gave the SSID the first question. So if you remove the first 40, I mean 40 bit or 20 byte, the rest is the text, and we have the key and the IV. So now we can get in decrypted text. So for example here it gives you all of that. So if we do the same things, for example we follow the next one is 74, we know this 20 byte is just a header, so there's no data was sent here. So if you go next, now we have now 164 length. So this data, 110 byte, we can copy it, and then we can go there, we can just copy there, and then we can see Windows system30 command.exe. So somehow, so we know in the right place. So we have now we have a 434 post request. So if you go copy value, do the same things, and now we get the part for the network. Now, so we know it's working. Now guys, I'm not doing the rest because not showing the answer, so you can follow manually and find all the post requests. Like the next one, this is 74, the next one is 164, and you do all of them to find it. Now the question will be, let's go back to the first one. The question is, we got the result of the command. Remember, uh, this is the result of the command. So what was the command? What was the server sending? Now, if you look to the server, the way that server communicate, so we look in, this is 38 is the client. Now, if you look back to the server, this is acknowledgement, that's normal, but he has sending a 174 data. We're not interested in this, or we should interested in the data. So the server send usually, like here the 74, here this is the acknowledgement, okay, and you send it in .ok request. For example, the next one here, he send another one 82. 82 we said is we are not interested because it is 0A. And look what happened in length. Notice very well here, the length is 12, not 20. The server, when he doesn't send, he doesn't use 20, he use 12 byte. So now it gives us an idea. This is where a bit I stuck myself on it. Let's go back. Where's the post of the server? The server is sending here at 74 line-based text. And this one, it's not. I think the first one is not the one we need to decrypt. Your next one is 82. Is, you see, it's 12 byte. We're not interested in the 12 byte. Okay. So your next move will be this one, the 82 server. 82. Let's see if there was it's again in 82. Because the post 74, it means you get an 82. It means they are not communicating. This is post 72, 74. Where is the next post 74? We're not interested on it. Where is the OK 182? Now we have an OK 111. So now we can interest in this data. It's not a 12 byte anymore. So now we can copy value. Now if you go to your server, it gives you now random numbers like that, and that's sometimes when you got stuck. But if you go to Havoc documentation of that, the server doesn't communicate, and you can see we found it here when we talk about the OK. Where is that OK that we got before? The OK 182. It communicate in 12 byte header. So common sense logic, we say we are not using the 20, we're using the 12, so it's 24. If you switch it to 24, look what happened now. We can see something happening. Username SID, and then you can see enable by default, and then you get some command appearing. So something the server sent is a bit strange what the first one, but we can see it's a 24. Now let's look for the next one that is not 24. We have an 80. Which one we just did now? This is an acknowledgement. we did this now. The OK, where is that OK again? No, this is the OK 182. We're not interested in that one. The post 74, we're not interested because his command was sent there. The 82, we're not. 82, you can see it's a 12 byte 0A, which is mean it's not communicating. Now we have something very interesting. We have an OK 287. Let's do this one. Let's copy, for example, this value and just paste that. And you can see it's an IP config. You can see the command now that server is sending. So it's sending IP config, and that's why the OK, when you do the post request next, the post request here, we can see it's a 64 byte. If I, this is the client to the server. The client to the server doesn't work in 24, it works in 40. And you can see the server is communicating, the client is back. So you can do the same things around these things. Like for example, here's a post of 434. Where is that? Okay. Sometimes I'm getting confused. For example, in OKF291, I don't want to show the answer, but let's see what this one. This one is the client, so it will go in 24 value. Now it is asking question of system info, so you can see the command that server sent. So basically, that's what exactly the whole thing is to do. 24 is server to client, 40 is client to server, and you just do it manually like that. You get the whole answer of the room. So basically, you follow down until you find the last answer. The last answer, for example, you can find it in the post request, not the 74, not the 74. You will see a bigger one here soon. This is 74, 74. Again, this is, they are not communicating. 74. This is this one, the 661. Here they give you the flag for that file. The last question, the last question is this one. If you decrypt this one, you can just copy this one, the 607 byte, with, because it's a client to server, so it's a 40 byte, and copy it there. You get, put it there, you answer. Now this is a manual way. It's not long because you have 5 questions. Doesn't take long to finish this. um, as I said, this room, they said we have this script. My problem, it doesn't get me the command and it doesn't decrypt first. So I use help with Grok AI to update it, and this is the, I will share link for this script. This one work, and that's when I run it. When I run it in my computer, I'm running it in virtual environment, so I don't have issue with dependencies. This is how it run. This is the script. If you don't want to do it manually, this is manually. If you want to do it manually, or you want to run the script will do decryption for you, and basically that's what it start. If I run it in the traffic PNG, so doesn't matter the error, wherever he can find the key, and then you start what we found here. Remember, we found these strange numbers. The first command, he find the command and the result, so you can see now the result, the first one. This is the decryption, just in memory. um, that's the ipconfig command. This is what is sending to the server. So yeah, and you can get the answer for now. This is the command for system info. I'm not scrolling down because it will show the answer, but the script, when you run it, it will give you the whole answer. So it show you all the command that the server is sending, plus all the command reply from the client to the server. I hope this video will work and it doesn't get black screen like last time. As redoing it is a problem for me. This is my second video. I hope, thank you very much, and have a good start of the week.